vem kan inte förstå svenska är också så på engelska. Vår nästa torre är Nicholas. Han jobbar på Anaconda och han ska prata om PyScript. Our next speaker is Nicholas. He works in Anaconda and he's going to talk about PyScript.
Woo! Well, thank you very much, folks. That's it. That's the end of the talk. So, I'm Nicholas. Thank you, PyCon Sweden, for having me. I hope you've all had a good time these last 2 days, and I hope perhaps to see you next year as well. It's important that we keep renewing this sort of thing as a community. I'm going to talk about PyScript. I'm Nicholas. I'm a principal engineer at Anaconda in the PyScript team. And I'm also Uncle Nicholas to Pi, and that is me and Pi quite a few years ago when I was visiting India. She's grown an awful lot since then. Okay, so PyScript, what's PyScript? It's a platform for running Python in the browser. But before we start that, I just want to give you a bit of context. This is me in my natural environment. I'm actually a classically trained musician, and software engineering is a big accident, okay? But I've been a software engineer for 20 years now. What we'll cover is some of the core concepts about PyScript. We'll explore it. I'll show you what it is. I'll give you some examples, and I'll also end by telling you where we're going with PyScript as well, okay? So, like I said, this is perhaps the most important slide in the deck that I've got here. So PyScript is an open source platform to bring Python to the browser via WASM. Now that sounds like, I don't know, buzzword karaoke. So we'll unpack that this afternoon. And I guess I'd better tell you the story of PyScript. Well, it was first announced this year by the Anaconda CEO, Peter Wang, in his keynote at PyCon US. I have actually embedded the YouTube video, I'm not sure why, into my slides, but I'm not going to play it for you because that would be rather too many layers of meta here. You're listening to me give a talk about somebody giving a talk. It's not really a thing that you want to do. So I think without further ado, I should probably show you what PyScript does. If you're interested, there are a lot more examples than just the ones that I'm about to show you at pyscript.net/examples. So, in classic computing fashion, the first example is Hello World. That's running across the network, and what do we see? We see Hello World, and the current time and date is blah, blah, blah. I'm still in the UK. My computer's still in the UK, in case you're wondering. And if I view page source, what do we see? We see between the PyScript tags standard Python, okay? And this looks kind of like HTML because it's a kind of arrow brackets tag, okay? And the only other thing that perhaps I want to draw your attention to is this script declaration up here in the head that points to PyScript.js, okay? Everything else is just regular HTML, okay? So, that's Hello World. So, we also can have a kind of a REPL-like environment. I'm assuming because you're all Pythonistas that I can talk about things like REPL and stuff like that, but it's a kind of an interactive terminal, if you're not so sure, where you talk to your computer in Python. So I can do something like 1 + 1, and then Shift-Enter gives me 2. And I can print hello, and I get hello, and so on and so forth. So it kind of works a little bit like a notebook. But here's the thing, and my neck is going to be really sore by the end of this talk if I keep doing that. Actually, I might do this instead. That's a lot better. Okay, so again, we have PyScript.js, okay, and then we just have a single tag called PyREPL, okay? And that's it, and that's all you need to embed a fully working Python REPL in the browser using PyScript. Oh, dear me. And now I've got rid of my slides, so what I'm going to do is do this. and this, and this, and that. And we're going to do this again. Okay, so we can do more than just REPLs and things. We can actually use real live Python modules compiled to work in the browser. So here's matplotlib. Over the network. It's taking a bit more time because it has to download all the various modules that we need and kind of do the equivalent of pip install. But if you're a data scientist, and by the looks of this conference, pretty much all of you are data scientists, you'll see that this is a kind of a nice data visualization. But again, view page source, it's just Python. There's PyScript.js, okay? And PyConfig is a new tag that I want you to know about because essentially this is like your requirements.txt, okay? And we're just saying we want to have matplotlib in our environment there, okay? And what else? Oh, this is a good one. Again, it's downloading a whole bunch of stuff. It's downloading some data. It has to get Python up and running. And then eventually, when I finish talking, you can see what I'm doing here, it's going to come up, yeah, with some rather sophisticated data presentation. And this is actually using a tool written in JavaScript that we've imported into the Python namespace. And there's a kind of a broker that talks to the two. And again, if you were to view the source, you'll get just plain old vanilla Python. And the last one, everybody loves a Mandelbrot set. Benoit B. Mandelbrot. Did you know that the B in Benoit B. Mandelbrot stands for Benoit B. Mandelbrot? That's, not many people know that. Some of you are listening. This is the graveyard slot in the conference, isn't it? Okay, there's the Mandelbrot of Julia, and so on and so forth. And let's view the source. And what do we get? We get some styles, and it's just Python that we know and love. Another thing that you perhaps need to know is that PyScript can have a source equals and then just a Python file. It's the URL to a Python file, and then it will just run that as well. So there we are. There's my Mandelbrot joke for the day. Imagine the potential. You have Python, and you have the browser, and what sort of extraordinary things could you do with that? And let's just think about that for a while, okay? Because you have Python. We all love Python. It's a very easy language to learn, so lots of people are learning it at school. There are lots of data scientists using it because although they might not be software engineers, orthogonally they're using Python, and because it's so easy to use and it has such a rich ecosystem of tools, that's why they're using it, okay? It's not just data scientists who use it. There are kind of app developers and all sorts of different types of industry that are using Python. So we have a very rich ecosystem. So we have this Python world on one side, and then we have the browser on the other side. I'm walking the wrong way, aren't I? The browser's this side, okay? We have the browser, which is the most ubiquitous computing platform on the planet. So all of a sudden, if you can run Python in a web browser, you can run Python anywhere there is a browser. And, well, you get Python on these sorts of devices as well, okay? So all of a sudden, and this is a kind of a missing link in the Python evolution, as it were, all of a sudden, we get Python on mobile devices, okay? So it's a kind of exciting opportunity to do something cool, okay? And what we're doing is we're marrying these things together. They are very different worlds, and we're just at the beginning of this journey as well. So for instance, the browser has a main thread, which is all event-driven, and if you want to do something that's computationally intensive, you stick it on a web worker, and there's lots of JavaScript and web APIs and blah, 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 blah. And then Python, usually, unless you're using async IO, is not event-driven, really, okay? And so we need to try and bring these two worlds together, and that's literally what my team spends most days arguing about, arguing in a good engineering sort of a sense, okay? So I've sort of shown you what it can do. I've given you a little bit of history. It's very, very young. It was only announced at PyCon US, which was in May, only a few months ago. And we can see there's a lot of great potential for Python in the browser. All of a sudden, Python's kind of everywhere, okay? And so let's explore how that works. So I'm going to try and help you put together the mental models you need so that when somebody says PyScript in that sort of conversational way that you have when developers get together, you can go, I know what they mean. And when they say WASM, you can go, I know what that means as well. And I also know how it connects to Python. So here's Guido. And we're going to start with the abstract notion of Python. Okay? And Guido represents perhaps the core developers or the designers of the language. And he's working out, well, what does Python look like? We do indentation. We define a function with the def keyword. We have colons. We have triple quoted strings. We have walrus operators and things like that. And that is, in a sense, an abstract notion of what Python is. Okay. Also, the core concepts that we use, like objects, are actually dicts, and we have other core sort of data structures like lists and so on and so forth, and it works like that. And the standard library has this, that, and the other in it. Okay, and that's how it works. So, in a sense, he's putting together the aesthetic of the language. Now, remember, I'm a musician, so I'm from a kind of an arty-farty background rather than a science and engineering background. So I quite like aesthetics and thinking about things. But when we're writing Python, we're expressing ourselves, and Python has a certain sort of aesthetic that it's famous for because we have, well, if you import this, what do you get? The Zen of Python, okay, which is a list of 19 sort of little sayings that explain just what the aesthetic of Python is. You know, simple is better than complex, complex is slightly better than complicated, and so on and so forth, that sort of stuff. And also, thanks to Guido, because he's a kind of an open, friendly sort of a chat, he's also steered the kind of the notion of what the Python community is. And just over an hour ago, we had a very inspiring talk by my friend Almusha about what it is to be in the Python community. Okay, so we have this abstract notion of Python in all its complicated glory, not just the programming language, but the aesthetic and the community that goes with it. Okay. And then we have implementations of Python. I was kind of stuck with this slide because I was thinking, how do you represent implementations of Python on a slide? And I thought, well, the best thing I can do is perhaps put their kind of little GitHub widget thing that shows you all the different sorts of implementations of Python. So you have the abstract notion of Python, and this is actually implementations that allow us to use Python. So we have CPython, which is the one that we probably use. You've probably heard of some versions like IMPython 3, which targets the Common Language Runtime, the Microsoft.NET platform. MicroPython, we've heard about earlier in the conference as well. That targets microcontrollers and very constrained computing devices, yet it is still a full re-implementation of Python 3. And at the bottom, we have PyPy, which, if you don't know, is Python implemented in Python. Okay, so these implementations are written in a particular language. PyPy is written in Python, okay? But CPython is written in C, MicroPython is written in C, and these are compiled, okay? And they are compiled to different target chipsets. So, yes, I'm going to be talking about compilers. It's Friday afternoon. This is going to be fun, isn't it? I might as well have said I'm going to be talking to you about the rules of cricket or something. But anyway, here we go. So the C is compiled to a particular target architecture. So I've put a few chipsets up there. AMD 64 is probably what you're using if you're using a laptop like mine. ARM is probably what you're using, or a version of an ARM chipset if you're using an Apple device. Intel x86, that's the old 386, 486, 32-bit stuff that we were using in the noughties as desktop computers. And then we have WA, or WebAssembly. Okay, now, that's not actually a particular chip design. It's a sort of a virtual chip. It's another abstract notion of what a chipset might be, okay, that you could compile to. WebAssembly, here's an important point here, is also called WASM. So when somebody says WASM, what they mean is that sort of instruction set that you are compiling to. It's a pretend chipset. So WASM provides near-native code execution speeds for any code that is compiled to WASM. It's very efficient. It's not a chipset, but it's a definition of the instructions for a virtual chipset implemented by a runtime like that which you find in your browser. Okay? It's a very young technology. There's still lots of exciting things to do in this space. Okay? And it's compiled with something called mscripton. okay, which sort of sits around at WASM and gives you access to the various bits of browser functionality that you might need, or it pretends away a virtual file system. So when you compile something like Python, which imagines it's going to find a file system, actually mscriptor makes sure that there is a virtual file system for Python to use, but in the browser, as it were. There are bindings provided by mscriptor for all sorts of, all the different web APIs as well, so it's quite powerful, so WebGL and all that sort of stuff. And it runs in the same sandbox as JavaScript does, so it's a battle-hardened sort of virtual machine, okay, when it comes to security and things like that. But it's not just for browsers. There is a tool called WASMtime that allows you to run WASM from the command line, as it were. Now, I want to be very careful about defining what WASM and Python is and how that relates to the browser, because for 20 years there have been, Python in the browser, it's going to be the next big thing, okay? And the way they usually work, and Brython is a very good example, Brython's a fantastic project, but what Brython is a transpiler, and that takes Python code and turns it into JavaScript, and then it runs the JavaScript on the browser. That's not what's happening with PyScript. What we do is we have regular CPython, and we compile the interpreter that you use on your machines to target WASM, and the WASM runtime is run inside the browser. Okay, it's real Python. It's just compiled to a different sort of target chipset, in this case, WASM. Okay? So there are several projects to bring Python into WASM, and the most mature is on the top left, Pyodide. Okay? And that started as part of the Iodide project. Pyodide has been around since, I think, about 2017, 2018, okay? And it's quite mature, and it's the full CPython, and they've also compiled things like NumPy and SciPy and other interesting languages that actually target C as well, so that they are available in the runtime that you could download, okay? So PyScript, by default, uses Pyodide as the runtime underneath it all, okay? But of course, there are other versions of Python, okay? So CPython, let's talk about the big Python logo in the middle. Thanks to Christian Himes, one of the core developers of Python. He has created the appropriate toolchain so that when people cut a release of CPython, not only do you get a version for Windows compiled for AMD 64 and Linux for AMD 64 and Apple for, ARM-based processors, but you also now get a WASM-compiled version of CPython. That is very early days. If you were in PyCon Berlin a few months ago, that was when he announced that he'd been up to this sort of thing. So it's only a few months old. Of course, we have MicroPython. This is a version of Python, like I said, that targets microcontrollers, very small devices that might be only as big as your little fingernail, okay? But it's still running a full version of Python 3. Without perhaps the full standard library, but MicroPython compiles to WASM as well. And of course, you know, these things, it's a young kind of ecosystem, and lots of things are crawling out of the woodwork. So I learned just before I came here that there's something called Zython, believe it or not, and this is Python compiled using a toolchain written in the Zig programming language, hence the Z in front of Python, so Zython. I have no idea what it is. It sounds very cool, though, and it's something that I'm going to investigate when I get back home, okay? But the point is that it is yet another version of CPython that via Zig is compiled to a WASM target. So where does PyScript fit into all this? Well, PyScript is the platform for using Python in the browsers. If you wanted to use Pyodide or MicroPython or any of the others, you would have to write a whole bunch of boilerplate JavaScript to get you to being able to execute Python in the browser. So PyScript kind of abstracts that away and gives you a kind of a common way of getting to Python, okay? It works with Python runtimes, currently only Pyodide, that target WASM, okay? It's browser native, So you don't have to configure a bunch of things with JavaScript. Actually, all you do is you write tags like in regular HTML. So it feels like it's of the browser. Remember, we're trying to marry Python and the world of the browser, and they're kind of quite different beasts. So what's interesting as an engineer working on this for me is we need to think, well, do we take the Python way of doing this or the browser way of doing this? And it's a very interesting kind of thought experiment to work out which one we should do. Anyway, we're making progress in that regard. And instead of doing a whole bunch of JavaScript to get Python to work, you just use the tags like HTML, as I was saying. And then PyScript takes care of the rest. We've shouldered that burden of doing all that boilerplate stuff and creating, hopefully, the right sort of abstractions so that you do get the browser that you know and familiar with and the Python that you know and you're familiar with, but we've managed to combine them in a way that makes it easy for you to write cool stuff, to just imagine what you could do if Python was in the browser type slide. So you could imagine all sorts of interesting new use cases for Python. And once again, this literally is all PyScript is. Okay? So I'm going to close because we've only got 5 minutes left. So what about the future of PyScript? Well, it's kind of closer than you think. When we announced PyScript in May, what you saw was a kind of a technical preview. Could we make it work? And well, actually, yes, we could. It created an awful lot of excitement. And as my colleague Antonio said, it feels like we've turned up the day after a really great party, and we've now got to tidy up. And so what we're doing now is taking all of the things that we learned doing the first version, the technical preview, and seeing what things we can make and build properly with test suites and blah, 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 and figuring out all the abstractions from the browser world and the Python world and how do they marry. We're trying to get that right, okay? And this is kind of where you lot come in, because when we make new releases of PyScript, things are going to change. It's not like we've announced PyScript, we've launched that ship, and off it goes. It's going to sail into the distance, okay? PyScript is going to change a lot over the next year as we settle down and figure out what the lie of the land is, what that problem space is like. So, if you're interested in this sort of thing, we have a Discord server. If you Google for PyScript Discord server, I can't believe I have to explain this, but some people want me to, then you will find where we are, okay? And come along and join us and talk to us. The core team is on the Discord server. So one of the things that I've been working on, just so that you know the sort of thing that I do as my day job, is actually looking, of course it's done this because there's a bug in the browser, looking at other runtimes. So this, my slides are in a browser, and actually this is MicroPython running in my browser, and it's been sitting there all the time, and I can do things like this, okay? And I have a REPL just like what you see on your regular laptop, okay? So that closes, essentially, the talk. I wanted to leave us with about 5 minutes for questions, because I know people tend to have lots of questions about PyScript, and I can't cover everything, so I want to hear what you're interested in, hence the opportunity for questions. So, the browser has actually captured my, there we go. So, any questions? That's it. Thank you. Okay, I can see 1, 2, 3, 4, 5 questions. Let's leave it at that then.
Hi. So
where's the disembodied voice? Okay, there we go. Hi.
How much network traffic do you need to use to just get it going?
That's a great question. So with Pyodide, the WASM file, which contains Python, is about 11 megabytes. Okay, which is still smaller than the New York Times website. Okay, if you're using, and it starts up slower because it's a big thing. Okay, MicroPython, as you saw, well, MicroPython is around 300K. Okay, so it's smaller than most images that you might see on a website. Okay, and it starts like that in several thousandths of a second. Okay, it's very, very quick. So that means, thanks to MicroPython, and this is why I've been looking at it, it's fast enough to run on mobile devices as well, okay? Next question.
Yeah, so I'm not one of those data scientists here. I'm just a common software engineer.
Common garden software engineer, yeah.
Yeah, and strangely enough, sometimes I don't just like write Mandelbrot visualizations.
Yes.
And I mean, I love fractals, but our business requirements sometimes, for some strange reasons, require different kinds of things.
Yep.
So if I would like to build like a bog standard like React application, but using PyScript, is there like frameworks around that, or how would that work, or is it even suitable for that kind of applications?
So that's a really great question, and that's something that we've been thinking about an awful lot. When Peter Wang, the CEO, announced PyScript, the technical press went, Anaconda says we're going after JavaScript or something like that. That's not the case. If you need to write React apps, go write React apps in React with JavaScript. You know, let many flowers bloom, and you know, technology is a very broad church, and we should use the right tool for the job. But remember, what I said is that PyScript is a platform, not a framework. It's a platform, okay? Now, in the springtime, I hope that we will have made enough progress that Anaconda, and I have various ideas about this, in fact, this is why I was hired, will be able to be in a place where we can start to write frameworks that allow you to create the things that you want to do on top of the solid foundation of the platform that we're writing at the moment, okay? But because we're creating a platform, that doesn't, you know, you could write a framework as well. And this is what we expect to happen over the coming months, is that people will, in fact, people have tried to start doing that. In fact, I've got a call with somebody on Monday about this, okay? So it's kind of coming. People are excited about it, and it's going to be like the early days of flight. You'll get some that fly, you'll get some that just go like that, and you'll get others that really are death traps, and you shouldn't go anywhere near them, okay? But you know, evolution will tell us what works or what doesn't work. But there are lots of people working in this space. Next question.
Yes, hello there.
Hello.
So which versions are being run, and where is that defined? Is that in the executable that you download the JS file, or?
Yeah. So we are running the latest version of PyDiet, which targets, I think, something like Python 3.10 at the moment. 3.11's just been released, hasn't it? With MicroPython, it's the latest version of MicroPython. Okay, I've got, in fact, the repo for my slides has MicroPython, and I compiled it and put the firmware file and the JS files in the right place so that it could be referenced by the HTML page that I have there as well. So what we expect to do is allow you to specify which runtime you want to use below PyScript. Because sometimes, if you're a data scientist, you want the full glory of Python with NumPy and SciPy and what have you, and that might take a few seconds to download because it's 11 megabytes and it's PyDiet and things, okay? And that's great. Okay, this is kind of edge computing. You know, you're going to be doing your data science in your browser. But sometimes you might be, for example, in an educational context, or you're creating an app that targets a mobile phone or something like that, and you want something that is just fast and immediate. Use MicroPython. Okay, so we want to give you the choice of what runtime to use. So there are mechanisms in place to do that.
That would be really lovely, because sometimes you just want to show some people that, hey, switch case, look at this thing.
Yes.
Or whatever,
yes.
New features.
Yes, exactly. There's the gentleman behind you, and then there was somebody over there, and that's all 5 questions. Yeah.
Thank you for a very interesting talk. And
Thank you.
I heard a little bit about PyScript on other sources. Well, when you make software, you have users, and users sometimes don't want to have a REPL or just a CLI application. They want to have a graphical user interface. So in the standard library, we have tkinter.
Yep.
Would you be able to run tkinter to convert just your common GUI Python app to something to run in the browser?
That's a really interesting question. So because of LLVM, which is what we're using to compile to WASM, if anything is compiled in C, it is written in C, it could be compiled to WASM in theory. Okay, so you could compile tkinter. I know the folks at Qt, however you say it, that there is a WASM version of Qt, so you could create your app with Qt and so on and so forth. So there are kind of desktop app type widget libraries that you could use. But I think that, most people, when they're using a graphical user interface, are actually using a browser-based thing most of the time. And PyScript has hooks into the DOM and the document object and the event system of the browser. So you should be able to create something like a React app that is client-based using plain old HTML, posh, plain old semantic HTML, and anybody who's a web developer used to the HTML world can sort of contribute in that sort of way. The other thing that I was going to mention is that Anaconda has another project called Beware, which was created by a mate of mine called Russell, and he has an abstraction of user interface libraries, so that you write once, run anywhere on Python, and Beware targets PyScript. We have...
Sorry to interrupt, but you can ask him afterwards outside. So
well,
thank you once again.
Thank you.